This section asks us to solve quadratics using the quadratic formula. In all of them, we'll be using the same formula, this idea that the value of the variable is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The important thing is that whenever you start, your equation is in standard form, which this one is. We have the quadratic term, followed by the linear term, and then the constant term, all set equal to 0. From there, we can pick off a, b, and c. A is whatever the, let me use a different color here. A is whatever the coefficient of the quadratic term is. So in this case, the x squared is by itself, which means it's understood to have a 1 in front of it. So a is 1. B is the coefficient of the linear term, which in this case is negative 2. Don't forget to bring the negative. And c is the constant, which again, paying attention to the negative, is negative 1. From there, we can plug those numbers into the formula. X is equal to the opposite of b. Since b is negative 2, the opposite is positive 2, plus or minus the square root of b squared, so that's negative 2 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, so that's all over 2 times 1. We want to simplify under the radical first, so that leaves us with 2 plus or minus the square root of negative 2 squared is positive 4. This first number will always be positive because it's always something squared. Minus 4 times 1 times negative 1. 4 times 1 times negative 1 is negative 4. So minus a negative 4 actually becomes plus 4. Pay very close attention to your signs in this step. All over 2 times 1, which is 2. If I continue to simplify under the radical, I have 2 plus or minus the square root of 8 over 2. Well, the square root of 8, if I do that off to the side, the square root of 8 can be broken down into the square root of 4 times the square root of 2. The square root of 4 is just 2, so that just gives me 2 square roots of 2. So x is equal to 2 plus or minus 2 square roots of 2 divided by 2. Lots of 2's. Every single one of the terms in this particular problem is divisible by 2. So I can simplify this by dividing everything by 2. I'm left with x equals 1 plus or minus, I'm dividing by the 2 that's outside the radical. This square root of 2, remember, that's not a 2. That's the square root of 2, which is 1 point something something. So I'm only interested in dividing by this 2. So 2 divided by 2 is 1, and I'm left with the square root of 2 all over 1. In 27, it's the same idea. My equation is already in standard form. It's set equal to 0. So I can identify that a is 1 because there's nothing written with the x squared. It's understood to be 1. B is negative 2. I have to be careful about the negative. And c is positive 3. Plugging that information into the formula, x is equal to the opposite of b. Since b is negative 2, the opposite of that is positive 2, plus or minus the square root of b squared, so again I have that negative 2 squared, minus 4 times a is 1 and c is 3. And that's all over 2a, so that's all over 2 times 1. This tells me that x is equal to 2 plus or minus the square root of negative 2 squared is positive 4, minus 4 times 1 times 3 is 12. All over 2 times 1 is 2. Keep simplifying under the radical. X is 2 plus or minus the square root of negative 8 all over 2. This looks very similar to the previous problem, but the only difference is we're dealing with the square root of negative 8. So when I simplify the square root of negative 8, I have to remember to include the I, the imaginary unit, to account for the negative. So that's 2 plus or minus 2i square roots of 2. It's exactly the same as simplifying the square root of positive 8. I just have to remember to include the imaginary, all over 2. And finally, just like last time, if I divide every one of these terms by 2, that leaves me with 1 plus or minus I square roots of 2 all over 2. For 29, we start off with a problem that's not yet in standard form. So to get it in standard form, I have to have the equation set equal to 0, which means I have to subtract 6t from both sides. If I do that, I'm left with 2t squared minus 6t plus 8 equals 0. An option I have here is to recognize that every one of these terms is even or divisible by 2. So to make my numbers a little bit smaller and a little bit more manageable, I can go through and divide everything by 2. That gives me the equation t squared minus 3t plus 4 equals 0. You'll get the same answer regardless of whether you do that division. It's just a step that's an option that kind of makes your numbers a little bit more manageable. So keep that in mind as something that you can do. Okay, if I identify A is whatever is with the quadratic term. In this case, the t squared is by itself, so A is understood to be 1. B is whatever's with the linear term, so that would be a negative 3. And C is the constant, which is 4. If I substitute those into my formula, I get that t is equal to the opposite of b. So b is negative 3, the opposite is positive 3, plus or minus the square root of b squared, so that's negative 3 squared, minus 4 times a is 1, and c is 4. All over 2 times a, so that's all over 2 times 1. Simplify, I have 3 plus or minus. Negative 3 squared is positive 9. Minus 4 times 1 times 4 gives me minus 16. All over 2 times 1 is 2. Continue to simplify under the radical. I have 3 plus or minus the square root. 9 minus 16 is negative 7. And that is all over 2. The only thing that I can do to simplify this is to acknowledge that I have a square root of a negative number, so I have to make sure I bring out that imaginary unit. This leaves me with 3 plus or minus I square roots of 7 all over 2. There's nothing I can divide all three of those terms by, so this is simplified. Again, with this problem, I want to put it in standard form, so that means subtracting the 6t from both sides to get that right side equal to 0. That leaves me with 2t squared minus 6t plus 1 equals 0. This time I'm not going to divide by anything because even though the 2t and the 6t, the negative 6t could be divided by 2, the 1 would give me a fraction if I were to divide it by 2. So this is going to work the way it's set up. A is the coefficient of the t squared term, so that is just 2. B is the coefficient of that linear term, which is negative 6. And C is positive 1. Plugging those into the formula, B is negative 6, so the opposite is positive 6. Plus or minus the square root of B squared, so that's negative 6 squared. Whoops. Don't need that. Minus 4 times A is 2, and C is 1. All over 2 times A, so that's all over 2 times 2. Simplify under the radical, that's 6, plus or minus the square root of negative 6 squared is 36. Minus 4 times 2 times 1 is minus 8. All over 2 times 2, which is 4. This gives me 6, plus or minus the square root of 36 minus 6 is 28, all over 4. The square root of 28 can be simplified into the square root of 4 times the square root of 7. The square root of 4 is just 2, so that whole thing is 2 square roots of 7. So this gives me that t is equal to 6 plus or minus 2 square roots of 7 all over 4. Every one of those terms is divisible by 2, so to finish it and simplify, 6 divided by 2 is 3, plus or minus 2 square roots of 7 divided by 2 is just the square root of 7, all over 4 divided by 2, which is 2. So I took every one of those terms and divided it by 2.